The music was created by Symformer.
Друзья, мы продолжаем наш эфир.
Friends, we're continuing with our session. And our topic today is the topic that inspires us to sin, to think. But I would like to give the quote of Leo Tolstoy. All the evil in man, one would think, should disappear on contact with nature, the most spontaneous expression of beauty and goodness. Animals evoke happy, tender feelings in us, but rapid climate change is affecting them with great force, and animals are affecting us, affecting our emotional state and even our well-being. Biodiversity conservation, the role of AI and challenges facing the experts. These are the topics that we're going to discuss with our guests today. I'm absolutely delighted to introduce this amazing trio. Olga Krever, Deputy Director of the Center for Protected Areas Support of the Ministry of Natural Resources of Russia, a legendary person, Timur Ionov, MTS, AI researcher, and Ivan Pigarev, Executive Director of the Association of the Development of Natural Beekeeping. Guests, hello, it's great to see you here in our podcast, and just a fantastic session, I think, and I hope that after this talk we will influence quite a lot of people. Hi, everyone. So we have an interesting trio today of experts because everyone has different professions, but everyone is connected with AI in different ways. But one thing in common is Flora and Fauna, and it would seem where AI in this area is. And today, I think we will give you the answers. I'll start with Olga. Fantastic job that you take, and can you tell me, please, what technological tools do you use in your work? Hi everyone, hi again. Great to be here. But let's start with Roszapovedcentre, the Center for Protected Areas Support. What is it? On the one hand, it is an organization that helps the Minister of Natural Resources and Environment to make the right decisions, including in terms of conservation and study of biological diversity. Secondly, it is an organization that provides scientific, methodological, informational and analytical support and human connection to the teams that coordinate the activities, now especially protected natural areas. There are over 12,000 of them in Russia now, but they are a little smaller. Just over 300 have the federal level. Of these, 240 are subordinate protected areas of the Russian Ministry of Natural Resources. Each reserve and national park is a small research organization, and you have to manage them all. I mean, some of them are smaller, some of them are bigger. And in accordance with the law on specially protected natural territories, they must conduct research activities and state environmental monitoring. How do you collect all those results that are delivered in the process of the scientific research in the specially protected natural territories? How do you process them? And here we have advanced technologies. First of all, we need them to organize the research work. We use such high-tech as unmanned drones that can fly and, without any human assistance, capture the life that takes place in a nest, for example, of birds of prey, or to look at some other animal. Do I understand correctly, as the next question I wanted to ask, is that you already use these tools in your work, and one of them you use for animal monitoring, of course, and research, because some biological and environmental research do not quite fit into the concept of monitoring. We're talking about applied science, applied research work. Then in order to understand where animals walk, what are their habitats, how are they distributed and concentrated in specially protected natural areas, we need cameras, camera traps and photo recorders. The most important thing is all our specially protected natural territories keep so-called chronicles of nature. These are unique works. The most valuable scientific information is collected there. How many researchers and years do you need to process them all? Obviously, AI comes to help here. What have you already implemented? You talked about the drones, and what are the results that they show you, and what is the difference? How these technologies change the way you work with data, and is the information more precise now? Well, in many especially protected areas, the species that are listed in the Red Book of Russia are studied and monitored as a priority. We're talking about birds of prey, big cats, cranes, and so on. To study them, some protected areas have already been using some drones for a couple of decades. But what is a quadricopter, a drone? It flies over the territory and takes pictures, and that's it. You draw a conclusion. But advanced and state-of-the-art drones of aircraft type, which can spend 14 hours without landing, without refueling, are capable of operating in harsh Arctic conditions. This is something that was used in our protected areas in 2022 when we had to monitor a polar bear on Wrangel Island. And this is a unique method that has proven its effectiveness. Moreover, the drones were our Russian drones called Orlans. We fell in love with them, absolutely, and next year we also started to monitor polar bears on other islands, and we didn't just fly these drones over these islands, but we used the neural network technology during the expedition. So this was a trained neural network, the AI, that determined where bears were and where they were not. And during the expedition, we received information about the number of polar bears inhabiting the islands. It's a unique approach. We did this world's first drone study of polar bears in 2022, and we were the first one to use AI for this purpose in 2023. The results were fantastic, and of course, without the partnership with government systems, scientific organizations, and business companies that supported this work, we wouldn't be able to deliver that. As part of the new national project called Environmental Wellbeing, we want to do some work for the Siberian crane, also using drones to study the Siberian crane, nesting sites in Yakutia, and help to restore the declining western population of Siberian crane using eggs that we will collect in places where it's abundant, and we will introduce the Siberian cranes into the declining population so that this population will recover. And such are the global plans that we have, and this is how state-of-the-art technologies help to restore rare species. This is a magic wand, really, that helps to reduce time and to avoid the human mistakes and get reliable information and do it quickly. Thank you very much. We'll move from the Arctic to Kamchatka. Timur, a couple of questions. You are a developer of a neural network for monitoring fish populations in Kamchatka. How did you come up with this idea in the first place? I understand there was a problem like that, but how did you realize that, okay, I'm the person who has to develop this system? Well, me and my team participated in an international hackathon as part of the World Festival of Youth in Sirius, and we had a problem put for us that accounting for non-rock takes a lot of time, and human resources of the fish takes a lot of time and human resources. It was necessary to create a system that would help to optimize the process, as it is important to control the number of the blueback salmon. 1 hour-long video can take up to 1.5 months of an expert's time. With the help of neural network, we were able to reduce that time by 95% for one person, while maintaining the same high accuracy. Since we're not talking about replacing a human, but creating an assistant that helps, pre-detects, and highlights what the expert has to focus on, and the final decision is made directly by the researcher, by a human. What was the most labor-intensive? The cameras are working near the water, and Kamchatka is famous for its difficult weather conditions. The cameras are just above the water, and sometimes it's very hard to detect these blueback salmon properly, and to resolve these problems, we developed algorithms that firstly try to eliminate various ripple effects and noise effects from rain and snow. Secondly, we trained the model to work in any environment. And, at the junction of these two important areas, using difficult examples to train the model so that it processes the data correctly, we achieved some good results. And this model can work all year round. How long did this test drive take you? We implemented this hackathon results in 3 days, and for the most part, we used open source libraries that allowed us to apply different effects, like the effects from the rain, from the blizzard. So we didn't have to create it from scratch. And it's also important to leverage the already available technologies and to orchestrate them properly. And we mostly orchestrated some other developments and adopted them from other domains and other areas. So the model we used was not originally designed for fish. It's just that we trained it specifically for fish and for that region. If you are an AI expert, you still need to be in the context of the domain in which you are developing a solution. So you kind of became a biologist during this time, yes. Has this development influenced your desire to further study biology and to immerse yourself in the topic of nature and animals? Yes, actually, during the hackathon, we immersed ourselves in the problems that people face, and we saw the effect that can impact the entire regions due to biodiversity. And we, as experts, as researchers, as techies, we know what tools can we try. We can prototype a solution, and we can make life much easier for the researchers and to leverage AI for nature. At the start of the session, I said that biodiversity affects us, our lives, and our well-being. I think many people know that up to 75% of the world's food is produced thanks to bees. And we have today someone who knows more about bees and their problems than anyone else. I'm going to start with this childish, naive question. We've all seen bees. It seems like, how could bees possibly have problems in the first place? But can you please tell me what's going on with them and what's the big deal? Like many other animals, bees have problems, the same problems as other species. Most of the problems arise because of the human factor. Bees are quite intensively exploited by humans, and this exploitation has a significant impact on them. It's very important to distinguish, if we're talking about nature and biodiversity, that bees should be considered separately as intensive agriculture industry, which is like beekeeping, and it should be regarded separately as an element of wildlife, because some bees are wild animals and are still wild animals. Sometimes they still live in hollow cavities. And I would also like to say that bees are not always honeybees. And they are very important for us, and unfortunately today intensive beekeeping unfortunately has a detrimental effect, including on the wild pollinator population, by creating significant food competition in certain areas. Ivan, another naive question. So it turns out that bees are affected only by intensive beekeeping, or are there other factors? There's a million factors. Pesticides have a huge impact, not only on bees, but on everything around them. Other pollinators, too, are affected by pesticides. But if bees are counted and people try to preserve them, because they deliver some economic effect. But as for all other species, no one pays any attention to them. But by the way, in terms of biodiversity, a large number of plants are in the Red Book just because they have lost their pollinators. So, let's go to the honeybees. There are a number of things and challenges related to honeybees. Some say that honeybees are on the verge of extinction. It's a nightmare. This is populist stuff, really. Honeybees are not on the verge of extinction. There's quite a lot of them. In terms of international classification, it's of minimal concern. It's the possibility of extinction. But within the honeybees, there are subspecies. And these are some populations that lived in a particular habitat, most often isolated, and over the course of the evolution, meaning a long period of time, they have developed a very stable gene pool that helps them survive in a particular place. And that's a pretty valuable gene pool we're talking about. And unfortunately, today, bees are transported from one place to another place in large numbers. And due to that transportation, there's a mutation process. And bees are crossbreeding with each other, and subspecies disappear. So there's another important challenge in terms of biodiversity is to preserve these unique subspecies. And so that these subspecies need to be identified. And there are different methods of identification. Mostly we use morphological traits. How to distinguish dachshund from the German shepherd dog, for example? Well, you understand that one have small legs, and you realize there are visual differences. And bees have also these traits as well, but bees are small. And there's another major problem. Polyandry. So each bee family has many fathers. So a female bee is breeding with a lot of male bees. So to understand which subspecies we're talking about, it's necessary to make some very complex measurements, some morphological traits, to look at the color, their feet, the pubescence. But the most basic method is used by experts is wing veining. There are certain veins on the wing of the bees, and it has been noticed that in different subspecies the veins differ in structure. Okay, so it's like we're talking about veins in the wings. Yes, absolutely. Ivan, so you have expanded on the problems of the bees and talked about the subspecies, but what AI tools can be used right now to preserve the population? How it can be useful in such a complex field? You should understand that AI is a tool. We are solving the problem of identification. So there is a process of morphometric measurements of subspecies by a wing vein pattern. Many wings are scanned, and certain points are placed at the intersection of their veins, and certain indices are counted. And this is a complicated process. I mean, there are some geometrical patterns that we have to identify. Anyway, now the process is as follows. We scan every wing, and to identify one family, you have to take 30 or 50 wings, and you have to put a wing to the scanner and scan it, and to glue it, and then to put these dots on every wing to understand the pattern of the vein, and then having a tool set that you have, you will get some result, some deliverable. Well, back to Timur. He was saying that AI helps to optimize this work. Optimize is a kind of a vague word, but anyway, can it help here? That's absolutely the same. I mean, the scanning process has to be manual, I mean, at least for now. But the process of placing the points on the win is a task that can be perfectly solved with the help of a neural network. And we have solved this problem together with a group of enthusiasts in several attempts to solve this problem in the world, more entomological ones, not only those related to honeybees. But we were not satisfied with the accuracy of all of these solutions. But fortunately, we found a team of people who decided to assist us, and on the basis of the neural network, we were able to develop a solution for this problem. So the placement of points is very accurate now, and the result is given and is delivered. That is accurate. And now we have reduced the whole process of measuring subspecies by about 2 times. This is a very promising software, needs to be developed and finished, fine-tuned, will be promising for many scientists all over the world. It's a tool not only for scientists who conserve biodiversity, but also for the breeders, bee breeders. I have to interrupt you here. But we're talking about the professions of the future. Now I have to skip to this topic. How will AI affect the profession of biologists, zoologists? What new professions will emerge thanks to AI? Well, I think now the biggest problem is that there are excellent experts in AI and excellent biologists. But this bundle is not working together properly right now, because in order to understand the task well, you need to have a very deep understanding of both these topics. So probably the profession of the future will be a specialist who is good in both of these things, and the person who will select tasks for the purposes of biology should know what AI can deliver. I would like to say that the most interesting and promising future professions will be at the intersection of different specialties. And it is necessary for specialists who are biologists and have fundamental knowledge to dive deep into mathematical methods of working in biology. We're talking about processing of large data volumes and other things. I'm very pleased to announce that one of such professions is being prepared right now. We're developing a professional standard for a specialist in the field of nature conservation. And that includes all the necessary skills and the competencies in data processing, including with the use of AI, the large data sets processing and monitoring. And of course, we will also provide fundamental classical knowledge. I fully agree with the speakers, and I think that the domain knowledge in biology and chemistry and other natural sciences will be valued. And the technology itself, the AI as a technology, is becoming cheaper over time, because it is making all this rapid progress, is becoming more and more publicly available. There are more courses and educational programs, and some of them are publicly available. We as developers do not have to reinvent the wheel every time. How did we manage to create a cool solution in these 3 days? Because we used the previous experience and the knowledge that we took from the internet. We just lacked the kind of a problem statement and problem knowledge from the point of view of the biology to apply it. So I think in the future, natural sciences will be still valued, and people, will have to train in AI to have an additional skill and to achieve these great results.
Well, right now the idea is that 5 to 10 years out, programming will be, relegated to the background, and the code will be written by AI itself. Neural networks are doing this already quite well. It's more about setting the task, framing the task for AI. Yeah, framing the task is the most important thing. At one point there was this profession of sorts, prompt engineer, and now it's sort of moving away. There's constant change. AI is developing at a rate that, in my opinion, no technology has ever been developing at. It's now clear that, in 5 years, coding will move to the background. Let me tell you this, with every passing month as a programmer, I write less and less code. Probably about 10% I write using my own hands. Everything else is written by the assistant. Well, it's good to have such positive forecasts. Dear guests, we have a small interactive activity for you in the finale. I would like you to pay attention to the screen. There will be a picture shown. Part of it will be covered by a blurred square. You'll have to guess what is hidden by the square. Is that a tick? That is a tick. What kind of a bug is that? Would you like me to name the specific type, or is that the specific wing type of it? Or is that a butterfly, or is that a bug, or... Well, it looks like a ladybird. It's like a ladybird. Well, let's have a look. Is that a tick? That is a tick. Ah, dear guests, that indeed is a tick. Ticks have been more actively proliferating, occupying new habitat, and they are spending less and less in hibernation. My question to you, can artificial intelligence save both humans and animals from tick infestation, from mite infestation? Well, if you look at this biologically, if some population increases too much, you need to look at the imbalances in the environment. It's not too likely to be just about climate change here. It looks like the habitat lost some predator that was feeding off these mites. You know, in all honesty, I know a lot about bee hunting ticks. There are bee hunting ticks. There's all kinds of them. They're very nasty, those ones. At the end of the day, do you think AI can project this? Well, project, yes. Because an upsurge can help if there's a confluence of factors. If, there's a confluence of temperatures, humidity, solar activity, there's an emergence of victimized vegetation, young grass. And then when these factors combine, we knew there were outbreaks last year, and if we do, and there's a confluence of these factors, we can predict the appearance of such outbreaks, upsurges next year, and AI can do this projection. And fighting that, project, yes, you can do that. Finding the patterns, a model can definitely do that. But solving that without a certain physical toolkit, without a new formula to spray, without creating the right habitat, without tweaking the habitat the right way, that should be done by humans. Next picture. Well, that's a living being, all right. That should be a living being. There's a lot of options here. That's definitely not a penguin. That looks like a marine mammal. Can that be a polar bear frolicking in the ice hole? Well, there's a lot of options here. Right. Well, that is definitely a marine mammal, of which a polar bear is one. Well, there's all kinds of hares and walruses and seals. Well, I've learned a lot of new vocabulary today, let me tell you that. Can we reveal the picture? Ah. Oh dear. These are killer whales. That's a strange killer whale. And in February this year, a flock of red-listed killer whales got trapped in an ice trap because of drifting ice. People couldn't get close to them for a while, rescue them. Do you think AI can help in such situations? Can we fantasize about a solution that might be forthcoming? Probably a similar case. We could be predictive. We could be assisted in forecasting. A forecast of an ice situation could lead us to identify some negative consequences for killer whales or other marine mammals. And based on that, we could position ourselves to help. And next picture. Why don't you show these pictures to an AI engine? They do a great job of identification. Well, who is behind here? It should be some fish. I think it's fish. This is, a bit long in shape. So, what is the guess? Is that a fish? Well, let's have a look at the right answer. And what we have is Amur tiger. In the Far East, a red-listed Amur tiger experiences problems with forage base. That's the wild boar population that's 8 to 10 times smaller than is necessary for the tigers. Both the tiger population and the inhabitants of populated areas are under threat. How can AI help in this situation? Well, I think the first asset coming to help should be humans. You know, AI is all well and good, but it was the humans who were to blame. It was the humans who exterminated the wild boar to such an extent that the tiger's food base, especially in Khabarovsk Krai, was undermined. So to restore the ungulates that live in Primorsky and Khabarovsk Krais, especially in Khabarovsk Krai, because the forage base there is much less diverse, to restore the forage base, we need to enhance that. Can a bioinformatician, for example, with knowledge of artificial intelligence, breed a new species of wild boars? Well, that's a different story. That's called introduction. That's a newly bred organism, hitherto unknown. They cannot be introduced. You can introduce them in specially protected natural areas because you can't run the consequences. You can't predict the consequences of this introduction. Maybe it will lead to an extermination of a lot of species. It might actually make the situation worse. There's a lot of cases like this. A lot of reserves know this. It's about exercising due care. Yeah. Well. Thank you very much for a very interesting conversation. I think whoever listened to us today will be very interested in doing all kinds of things in fauna and flora. Earlier we mentioned that climate and biodiversity are directly related to agribusiness sector. Due to rapid climate change, we are already seeing a decline in yield growth of one of the most popular crops, maize. Shortages of cocoa products, chocolates are predicted. Even potatoes could become a real delicacy. How AI can help crop yields? What smart farms are? Is that a matter of long out future, or is that a reality already? And what will an agro specialist look like? That's the topics for the next discussion.